And welcome back to Educator.com and this series on AP Computer Science. Today's lesson is about equality, relational, and logical operators. In today's lesson, we will talk about equality and relational operators. Relational operators would be things like less than and greater than. Then we'll talk about logical operators. Logical operators deal with Boolean values, true and false values. We'll talk about short-circuit evaluation, which is a way that the compiler more efficiently evaluates the result of complex Boolean expressions. Talk about De Morgan's laws, which are a couple of laws that give interesting properties of Boolean values. We'll look at truth tables, which are a way of determining the value of a complex Boolean expression. And then finally, we'll conclude by talking about operator precedence. That is, when you have multiple operators in an expression, what order are they evaluated in? The equality operator, equal to, is two equal signs. Now, it's very important to remember that when you're testing for equality, you must use two equal signs, not one equal sign. One single equal sign is the assignment operator, and that would be, for example, I equals 10. A single equal sign assigns the value on the right-hand side to the variable on the left-hand side. Equal equal tests the two values for equality. So this expression assigns a value of 10 to I. This expression compares if the value of I is equal to 10. They're not identical. And if you use this, where you mean to use this, you will end up with program behavior that's not what you expect. You'll end up assigning a value of 10 instead of just determining if the value is equal to 10. Not equal to is the exclamation point followed by the equal sign with no space in between. This is determining if the values on the left and right side of the operator are not equal to one another. Then we have the relational operators less than or equal to, greater than, and greater than or equal to. Whenever you have two characters in an operation, it's important not to put any blank space between them or they will not work correctly and you'll likely get a syntax error in the Java editor. Now these operators should only be used for comparing primitive types. If there are user-defined types that are implemented as classes, then you're going to want to use either the equals method of the class or the compare to method of the class. These methods allow you to provide any level of sophistication that you need to in determining whether two values truly are identical to one another. For the primitive types, these are fine, but for anything more complex, you need to use either equals or compare to. Logical operators. Logical operators are operators that deal with Boolean values, and there are three of them. And is two ampersands with no space in between them, or is two vertical bars. Vertical bar is the character that you make when you hold down the shift key and hit the backslash key. And so two of them is or, and then not is a single exclamation point. The definitions of these operators are that A and B is true only if both A and B are individually true. If A is true and B is true, then A and B are true. Otherwise, any other combination, if A is false or B is false or both of them are false, then putting them together with an and results in false. Or A or B is true if either A or B is individually true. or if both of them are true. So if A is true, A or B is true. If B is true, A or B is also true. If both of them are true, A or B is true. A or B is only false where A is false and B is also false. Not A is true if A is false, and not A is false if A is true. So not simply reverses the value of a Boolean that it's placed in front of. If the Boolean is true, not makes it false. If the Boolean is false, not makes it true. So here are some examples in how these logical operators are commonly used in Java code. We can have two expressions here. X is greater than or equal 1. X is less than or equal 10. If we join them with an AND, that means that X has to be between 1 and 10 inclusive. This is a very common type of expression that we need to do. If we're looking to determine if a variable is within a defined range, we would use the lower end of the range, the upper end of the range, and join them together with an AND. Here's an example with OR. If y is equal to 0 or z is less than 0. If either one of these is true, or both of them is true, then the entire compound expression is true. And here's an example with not. If not found, and this is equivalent to if found is equal to false. This is something that we might use as a loop test to determine if we want to continue running the loop or not. If we have not found what we're looking for, we continue the loop. Once we have found it and found is true, then we would exit the loop.